welcome to the first of a series of tutorials I'll be releasing over the coming weeks, in which I'll build a simple game in Quill from zero to something that should be playable, hopefully on a Spectrum or on an emulator. I'll be going through the basics, building some sprites, tiles, rooms and so on, and then covering some of the more advanced techniques that can be used to maximise the available space, available performance you have on such a constrained platform. So for those who aren't already aware, newcomers to the channel, welcome. Quill is a new retro focused game creation tool. It's targeting very early platforms, low power platforms. Initially the Sinclair Spectrum range of computers, including the new Spectrum from Retro Computing. So it's building games on very limited constrained platforms, and we'll be looking into how ways that we can maximise what limited resources you've got available on those platforms. So without any further ado, let's get into the tutorial. Okay, so the first thing we're going to need is a sprite for the player character. We'll do something non-animated at the moment, and I'll work from previous material to make it fairly quick. But we work in the sprite editor. We paint with always with white at the moment. You can change the colour of the sprite later, but we'll paint with white to begin with. As I say, basing it on an existing character. The important thing I want to cover while doing this is not the actual sprite drawing. It's pretty standard stuff. It's anyone who's done any bitmap drawing will be fairly familiar with it. But there's different modes of working with sprites in Quill, and the one that we're going to be using here is called mask mode, which masks out the background and gives you a much clearer definition of your sprite. So what I'm drawing now is I'm clearing any pixels that won't be drawn as part of the sprite, and what that basically means is where you can see the checkerboard, any pixels that are in the background where the sprite is being drawn, if you've got a background, will show through. Anything that's in the middle that's not checkerboard will be cleared first. That's what the mask does, it clears, and then it will draw the sprite over. So in the hair, for example, where you can see the black in the hair, that will remain the background colour. The background pixels won't show through, and similarly the boundary where you've got that the thin line around the outside, and that's a very useful approach to ensure that your character stands out from any complex backgrounds you might have in your game. Okay, so before we get into the next part, which is going to be designing the rooms and the tiles, I just wanted to go into a little bit of detail about how this game will work. What I wanted to do was build something that allowed me to have multiple rooms in the most cost-effective way possible. So the technique I've chosen to use is to use a single room definition and then use that room definition multiple times on the map and apply some logic to change the configuration of the room to make it look different in each location. So what we're going to need to build to begin with is a bunch of brushes. Just a very quick explanation. A brush is a collection of tiles that are held separate from a tile map and can be pasted repeatedly on a tile map very cheaply. So if you're designing rooms that have a lot of areas that are very similar, or you have similar sequences of tiles in multiple rooms, using a brush is a much more efficient way of doing it than painting the tiles each time. So we're going to design some brushes, and as you can see here, this is what we're aiming for our basic room layout. So we've got the four corners, so the room layout will look like that when we're done, and each one of those four corners will be stored as a brush, and we'll implement some variations on them as well, so you can choose which brush to put into which corner and therefore get some room variations. So that's what we're going to be working on now. Okay, so the first thing we must do is create a room, and we'll give it a name so that we know what we're working on. And then we've got to create some tiles to use in our room. And you'll have seen from the previous picture that it's a forest style, or forest or woodland type game. So we'll create some grass or some plant type tiles, very simple ones. As you can see, you draw in white by default in the tile editor as well, but we can change the color. So we'll change it to green and set the collide flag so that it can't be moved through. This means that the player won't be able to get through these green ones. The green ones are the most important ones because they form the boundary of the room that the player can't get through. We'll create a couple of variations of it so that it doesn't get too repetitive. We can just have some slight variations. They'll all be the same in terms of their behaviour. We'll change them to green, and we'll make sure you can't go through them. Three variations should be plenty, just to add some variety to the most prominent part of the room, which is the boundary of the area. So again, we'll do this one as green and fully collidable. Now for the next part, we're going to take a copy of one of these and just make it blue. This is for the first layer of fading out. It doesn't need to be collidable, so we can disable that. Now we can't go much darker than blue without going to black, so what I'm going to do here is just stipple effectively the tile by removing some of the about 50% of the pixels, which gives it an even darker appearance. So what we end up with is 3 tiles that we can use, or 3 layers that we can use as you go deeper into the woodland. So to create the brushes, we need to first of all work out how big we want each corner to be. So let's draw in some placeholder squares just to see what the room would look like. Each corner must be the same, so if we measure, and I'm going to be aiming for doors on the exits that are 2 wide by 3 high, so leave that space in between and we get a clear picture of how the room will look in terms of the corners and the exits. So once we're happy with that, we can change the size of the game window. Reducing the size of the game window is a good means to improve memory efficiency. If you don't need all that space around the outside, you're not going to use it, the room is constrained to that smaller area, then reduce the window size and you save a bit of memory on export. So now we'll copy one of these into the copy buffer and paste it down as a template to start drawing in our brushes. So once we've got that as a size guide, this is the size we're working with, we'll remember to switch into tile mode and then just draw a random rough boundary of the room in green. Remove all the other stuff, and then, as I said, use the blue and the stippled blue to give the appearance of the woodland getting darker as you go deeper into the woods. So once you've done this and happy with that, with the fading, we need to copy that into a brush, and this is our first brush. This is going to be our northwest corner brush, or default northwest corner brush. So as you can see, it creates a brush with all the tiles in. It does contain the colour information, although the colour information is embedded in the tiles, so it doesn't show in the brush at the moment. So now we can do that for the northeast corner as well. Same thing, copy in from our buffer. It was still in the buffer, we hadn't changed that, so no need to copy again. We can just paste and draw in a random green outline that just looks sort of rough and natural, and fill in our fading background. Copy that as a brush and move on to our southwest corner. Same technique, just draw in a green. You'll see I'm not using the variations of the green at the moment. The most important thing is just to get these in. I can go back and I'll show you how to use replace brush, the replace brush tool, so that we can actually add some variation to the green later and just replace the brush. And this is why I'm drawing outside of the room. You'll have noticed I'm drawing all of these brushes outside of the room window. So what Quill will do when it's exporting is it will ignore any tiles, brushes or collision information that's outside the window, so they don't contribute to the memory use, which makes the area outside of a window a very good useful space for like a scratch pad, which is what we're doing here. I can keep these in here, we save them with the Quill data, the game, and have them there so we can go back to them and maybe modify the brushes, tweak them, to get what we want, but they don't contribute to the game, so they're not costing any memory. So there we have 4 basic brushes for the basic corners, and that shows the room in its default configuration. So what I wanted as a second set of brushes for now is a variation on these that has each corner has like an alcove into the corner, which is a place where I can put things to be collected. So we'll just take a copy of the default position and then modify it to give this little alcove, being careful to make sure that each point within the alcove is at least 16 by 16 pixels, because that's the size of the sprite, and the collision is on the boundary of the sprite. So if it's not big enough, you won't be able to get in there to collect whatever we're going to put in. So again, we copy a brush for that one. So now we have 2 northwest variants, and we'll do the same for the northeast, southeast and southwest, each time creating an alternate version of the corner with a little alcove that we can put keys and collectibles and things like that, and maybe put sentries or something on. Now this one is slightly different in that you'll see the top line or the top area is not green. Now this means that the player could potentially walk through that and get out of the game and cause all sorts of problems. So we manually put in some collision markers in there rather than putting them on the blue tile. We don't need them on all the blue tiles, but just those few. So I can manually put in a few corrections, if you like, just to make sure the player can't walk through that area when they're playing. So one more. After this, we'll cut another brush. Again, that one has to you have to mark that blue area as not penetrable, otherwise you'll be able to walk out of the game. In this last one, I just wanted to add a little bit more variation, and instead of just having a single alcove, I've decided to see if I can fit 2 alcoves in, just to make it a bit more interesting. We've got plenty of space, so it should be possible just to put a small centerpiece that splits it into 2 areas that can be reached, which gives us a bit more variety of places to place things that you can collect. Again, this one, because it's using more of the space, is going to have a lot more of the outside edge as not green, so we need to make sure that we close that off so that the player can't sneak through and get out of the game. So now we've got 2 sets of tiles, 2 sets of brushes for our corners, and we can choose between them and mix and match to create a variety of rooms. So now that we've got the corner pieces in place, we've got these gaps in between each corner on the north, east, south and west side. Now these can be in one of 3 states in the game. They can either be open, as they are now, which allows the player to traverse through and go to any neighbouring rooms. They can be closed, which will be a similar brush with the grass or the foliage tiles in, or they can be doors. So for now, let's create the closed brushes in the same way that we did with the corners. You'll see that in both sets of corner options, I've intentionally left the green tiles at the 3 down from the top, 3 up from the bottom, and 2 in from each side, to allow for the standard door size of 2 wide by 3 high. So these blockers, or these closed brushes, will work absolutely fine in both sets of tiles. I don't need 2 sets of closed brushes, which is handy, saves on a little bit of space. So if we just cut these brushes out now, and we'll leave them in the scratch area, so they're there if I want to come back and make some changes and redefine the brushes. But for now, we've now got the 4 closed brush closed exit brushes for the north, east, south and west. So the next thing we need to move on to is our doors. So to create the doors, I'm going to need some new tiles. I can build it with 4 tiles, even though it's actually 6 tiles, because the 2 main body can stack on top of one another. And I'm just going to add a little bit of variation in there to make it more interesting than just pure solid colour. Trying to give the effect of a bit of random wood grain in there, vertical wood grain, just by adding some markings. And then I can duplicate that one. So that'll be our left part of the body, duplicate it, and then just change the markings and add a hinge so that we can see which side the door opens on. And then for the top and bottom, I want them to be rounded slightly to make it a bit more interesting than just a square door, but again using the same technique to give a little bit of interest to it by simulating some wood grain type effects, trying to make sure that the wood grain matches the tile that will be underneath it so that it looks like it continues from one to the other. And what I'll use to make this easier for the other side, once I've completed the wood grain on this one, is the flip tool, which just mirrors the tile immediately, and then again replace the wood grain pattern so that it lines up with the tile that's underneath. And we'll see that this works when we paste them into the scratch area. So we have the 2 top ones, and then we can place 2 of each of the side ones underneath to give a door with 2 hinges. Now, obviously doors you can't go through, so we'll make all of the door tiles fully collidable so that they prevent the player going through them. And that means we don't need to paint that when we create our brush. But for the actual door brushes, I'll paint in the tile map and then cut the brush. That will take the color information into the brush along with the tile information, and then I can just paint it in green and then blue and then gold to create each one. And the color information is embedded in the brush, so we have these four versions of our door, all of them solid because they all use the tile with the included collision information. So that's our 4 doors, which we can now place, and I'm going to create, using the empty tile, a very simple empty tile, and critically blank collision, a brush that I can use to remove the door, which we'll see when I get into the logic. So that basically wipes out any tiles and any collision information that's in use in that door when you open a door. So now that we've got all the brushes that we need for now, we'll need some logic, and that logic will be responsible for painting the brushes effectively when you enter a room or enter a location, based on how you've configured that location with various. So we're going to start in our logic view in the logic editor by creating a room entered trigger. So this will be executed whenever you enter a location on the map that uses this room definition. And we're going to need paste brushes, obviously, because that's why we created our brushes. Now there are 3 variables or 3 inputs to the paste brush: the position and the brush type. We're going to get the brush type from a select, which allows us to very easily configure which brushes to choose based on an input variable. The select node is very handy. It takes an input number and uses that to choose from a list of values that you specify, which I'll add in a second. It works in 2 modes, either wrap or clamp. We'll use clamp because it means that any values less than the minimum will be the minimum, any values greater than the maximum we'll just use the maximum, so it just chooses within the list that we define. So let's create some input variables that are going to be set on each location for which corner variation to use for each corner: north, west, northeast, southeast and southwest. Now these will be initially 0 or 1 because we've got 2 variants, but they map to different brush indices based on which corner. So for the northwest corner, its brushes 0 and 4 are variation 0 and variation 1, and they're very easily up at 0, 0, so the coordinates can stay at 0, 0. So then we'll cut and paste that sequence of 3 nodes, because they're going to be the same for each. The node types will be the same for each corner. We'll just change the values as we move on to each corner. So if I cut and paste each of those, so we get this nice sequence. It's always good practice in logic to try and keep your graph looking as tidy as you can, because it makes tracking down problems a lot easier if you can visualize the flow. So on the second one, we'll change the variable input to northeast, and the brushes are 1 and 5. And to make sure that we're putting it at the right place, I'm going to paste a brush temporarily into the map, so that I can just see for certain which tile to put it on. I can read that from the cyan values in the bottom left. So I believe that was 12, 0. And then moving on to the southeast, the brushes for this one are 3 and 7. So that's all we need to change, is that to 3 and that to 7. And then the position of this one, we'll do the same thing. We'll grab a southeast and then read off the values of 12, 11, and copy those in to the paste brush node. And then finally southwest, which are brushes 2 and 6. So we'll set those up. And the position, again, we'll paste a sample one in there just to make sure that it looks right, and that's 0 and 11. So if we copy that information back to our nodes, that should be sufficient now for us to be able to place a copy of this room on the map and configure the corner coordinates and see if it works. So if we go quickly to the map, we'll drop one into place anywhere on the map, it doesn't matter. And you can see we have, if we go to the properties, we have these 4 variables. So if they're all set to 0 to begin with, it should use the first variation, and that's what we get, the first variation. So let's just check that this is working by changing them all to the second variation, and we should get the alcove versions of the brushes. So, and you can define any combination of alcove and non-alcove to create variations of the room. So this is very powerful to create a variety of different rooms and combinations of those brushes. And we can always add more brush options later if we want to increase the flexibility. Next, we're going to need to update the logic in the room to place the exit brushes. So to make this easier, I'll put in the close brushes as placeholders, and we can use these to determine the correct coordinates, make sure they're being placed in the correct at the correct point in the map. So if we place all 4 of those, we've got those for reference when we come to calculating the coordinates. So back in our logic, we'll have a very similar flow to the corner ones. We'll do it as a separate flow just to keep things tidy, otherwise the single flow on room entered will get a bit messy. They'll both be executed on room entering in no particular order, which is absolutely fine, but it just keeps things a little bit tidier. So we'll need, again, it's going to be very similar. So we've got a paste brush, and we're going to have a select. The select will have a few more options in it because we've got more choice. I'll create the 4 variables to allow you to configure which exit type for each of the 4 directions: north, east, south and west. And this will allow you to configure between open, and that you can travel between rooms, closed, which is the brushes that I've just placed in there, and any of the 4 coloured doors. So you're going to need 6 entries in the select here. We'll make sure it's clamped again to ensure that any out of range values are just clamped to the minimum or maximum. So we've got 6 values. Now we need to work out, this is going to be for, the first value is going to be for the open space So we'll use our blank brush that we created with no collision information in it at 16. That'll be the same for each one. For the closed, it's going to be different for each exit. So this one, the north door is 8, and then the rest are the coloured doors, which are going to be the same for each exit, so we can reuse those quite easily. So much as before, we'll cut and paste for each of the four directions, and modify. The only thing that needs to be modified in the select list is the closed brush, because that's unique for each direction. So if we cut and paste another 2 of these, we should have all exits covered. This one will be brush number 10 for south, and then finally we can paste another set for the west brush. Sorry, the west exit, which will be brush number 11 for the closed. So now we can go back to our map and just take note of these coordinates again, using the cyan cell indicator in the bottom left, and just transfer those values across so we know we're pasting in the right place, and just modify the variables while I remember. And then we go on to the south brush is there, and lastly the west brush, which is at 0.8. So if we put 8 in there, so those two flows should be sufficient now to be able to completely configure the room in terms of the corners and the exits. So if we go to the map and bring this up, we can see now we've got these additional 4 variables that we can tinker with. If I close them all off, we should see in the preview that they're all now closed, and we can go back and just try various different configurations. I can put in the doors, for example. So if I change them all to standard corners, and then in the exits, if I put in the numbers for the 4 doors. So remember, the doors are 3, 2, 3, 4 and 5, because 0 is open and 1 is blocked. So this should show us all 4 doors now. There you go. So now we've got the ability to very easily configure which corner combination and which exit combination for each location on the map that uses this room. So we can define a whole bunch of rooms and have them all look slightly different and appropriate for how we design our puzzles and placement of objects to be collected and things like that. So now that we've got our rooms in place, we're going to need a player that can move around within those rooms, and we can test that. So if you remember back at the start, we created a sprite, and we haven't done much with it since, so now's the time to create an object using that sprite. I'll call the object player for obvious reasons. We'll make sure we set the mode to mask, because we did draw a mask, and add that single frame just as the single visual. We'll drag the player object into the map, which makes it a map level object, which means it can move anywhere on the map from room to room. It's not tied to a specific room, which is what we need for the player. For the logic, we'll run some code on every frame, which is what the always does. We'll use the controller input, and we'll set the left and up values to -1 and the right and down to 1, which is the directions in X and Y that we want to move the player. We add the 2 left and right and then the 2 up and down values together, because if the player is pushing both up and down at the same time, this will mean they cancel each other out, so you don't get some strange behaviour where it tries to move in one direction and it can't decide which. Then finally we take the output from that, which will be -1 or 1 or 0 in each direction. We add it to the current X and Y position to get a new X and Y position. So the output from these 2 maths will be our target X and Y position, which we just feed into a move object node as the X and Y positions. Make sure we get it in the flow so that it's actually executed, and that should be sufficient. We're not going to do any collision detection at this point, but that should be sufficient to allow us to move the object around using the left, right, up and down keys, as you can see there. Now you'll notice that I can walk through the doors and the and the background. And this is because when you instantiate or reference an object in the map, for example, you have some object properties, and you have to make sure that you set the collision flags in there, otherwise it won't try to collide with any elements when you move with the move object node. So the next thing we need to attack in this part of the tutorial is enabling the player to open the doors that we've placed in the room. Now, to do this, we need to detect when the player has collided with or intersected with the door. We can't do that with the door itself because the door is based on tiles, and the only thing we have the ability to detect individual intersections with in Quill is objects. So the easiest way to solve this is to create an empty object, and by empty I mean an object with no sprites. So it doesn't show, but it is there, and it's subject to the same logic and collision as every other type of object, and we'll use that to detect when a player hits a door. So we'll create a new object and call it door detector and leave it at load, and we just won't bother adding any animations to it, so no sprites. We don't actually need any logic, but we will need a single variable, and you'll see why we need that when I implement how the doors open. So to get the placements correct, I'm going to just temporarily place the corner brushes into the room just as a visual aid, so I can make sure that the positions of the door detectors are correct. So with those in place, we can drag our empty object. As it has no sprites, Quill will show it as an outline, and we want to place it so that it overlaps the 2x3 area of the door by just half a tile, 4 pixels, just so it sticks out a little bit and gets the intersection. And we'll call them appropriately. So this is the north door detector, and then we can drag in ones for the other sides as well. So we get one in the east, again just overlapping the door area just by a little bit, just to make it detect the collision before you actually get to the door. And the south one, which we'll rename south door detector, and then the west door detector, which we'll call, not surprisingly, W door detector. So that's those in place. So now that we've got the door detectors in place, we're going to need to detect when we hit them, and we do that within the player, which is where we're doing the movement. So first of all, we want to do a check to make sure that the object we're hitting is of type door detector, because that's the one we're interested in at the moment, and we do that by using the isType node. Now the response for hitting a door is going to be remove the door, but the room should be responsible for that, not the player. We don't want to have things going on in the player that aren't related to the player. So the best way to do that is to tell the room that we've hit a door, and we can use that with the message room node. We're going to need to read a variable out of the object that we've hit, which is the side, which I mentioned before, and we'll assign a different side value for each door detector. We need to make sure that the get object variable is in the flow, because it has a true and false state on the way out. It can succeed or fail, and then we can use the value of that side variable to pass into the message. We'll use message 1 as parameter 1, and that will tell the room that we've hit a door and what side of the room the door is on that we hit. And we can do that entirely within this code by using the variable on the door detector, and it just needs to detect an object of type door detector, and then read the variable off and pass it over to the room to say this is the door that we've hit, do what you must. So now we need to go to the room, and we need to respond to the message that we're going to get from the player. So we use an onMessage trigger for that. Make sure we set the matching ID. If you remember, we set the ID that we're sending the message as on the player as 1, so we must listen to an ID of 1 on here. And we're going to read in the variable P1, which, if you remember, was the side of the room that the door detector was on. So we're checking just for north at the moment, so we'll do one at a time. And I'm going to implement the door opening as a subgraph, which means we can reuse it. So we'll call it open door for clarity. And we must have a flow in, so the subgraph always comes in at an input point, a single input point. And we're going to need some input variables which will show up on the subgraph when we go back out as ports that we can attach values to. So we're going to need to know a door type. We don't need to worry too much about which colour door it is at the moment, but we do need to know if it's a door or if it's an open space or a block. The brush type basically. If it's less than 2, then it's open or blocked, which means you can't open it. The door open code can't actually do anything with that. So we'll output a value on a named output called didOpen as 0, just to indicate that we didn't actually open the door. If it's greater than 2, then it's one of the doors. At the moment we're not worried too much about which door it is, but we're going to paste the blank brush over it anyway. We're going to need a couple more input variables, x and y, for where to paste it. And the brush number is going to be our blank brush, which was 16. So we'll put 16 in here. And then the last thing we do is set the output variable, the same named output variable. There'll only be one port called didOpen, but its value coming out of the subgraph will depend on which flow it follows. In this case, we want to set it to 1 to indicate that we did open the door. So now you can see we've got these input and output variables ports showing up on the open door subgraph. So we're going to feed into the door type the north exit variable, because we're looking at north, only at the north door detector at the moment, and we need to know the door type, which is on the north side of this room, and that's stored in the north exit. So we'll set the position to 10.0, and then we'll check to see if we actually did open, i.e. the output value is not 0. And if it is not 0, then that means the subgraph did open the door, and we should set the north exit to 0 so that when we come back in again, the room entered code will set the exit location as 0, which is open. Let's take a moment to go through in the room and make sure that the door detector sides are set up properly so that it knows which side we collided with. 1, 2, 3, 0, 1, 2 and 3. 0 is north, remember that's the only one we're checking at the moment. So if we run this now, we should be able to open the north door. There we go. The others won't open because we haven't added any logic yet to check if the side that the message passed in is anything other than the north. So you can see how the variable changes, the north exit variable changes so that it remains open as you move from room to room. So now that we've proven that that works, we can duplicate that part of the flow for each of the sides, and we're reusing the open door logic, the open door subgraph, so we don't have lots of complex logic in there. It keeps things a little bit tidier. And when we come to implement keys later on in another part of this tutorial, we can do that in one place in the open door subgraph, and it'll apply to all of these flows. So I'm just going through very quickly, doing the obvious things, which is to change the location and the input variable and the variable on the output if the door's opened, so that each side is handled properly as we come in. So if it's type 2, which is south, then we want the south exit variable, which for the door type. The position is going to be 1016, so we'll update the inputs to the open door subgraph 1016, and we'll change the output variable set to south exit, and then finally for the west exit, which we'll update in the same way. So we follow the flow on. If it wasn't the south exit, we'll check to see if it's the west exit, which is 3. Read the variable in. We'll check our positions, which we can read from our room entered code, so we don't have to recalculate them again. That's 0 and 8. and we'll change the west exit variable to 0 if the door was opened. Make sure we connect the P1 parameters to each of the if nodes so that we know we're checking the right thing, and that should be sufficient to be able to open any of the doors by touching them. So if we go quickly to here, we can now open the west door and the south door and the north door. I haven't got a door on the east, but as you'll see, if we go out and then come back in again, that state is retained by the setting of the variable at the end. So I think that's a good place to leave it for the first part of this tutorial. Let's just recap what we've covered. So we've created some sprites, we've with masking and shown you how the sprite editor works. We've gone into some detail about how the room mechanism is going to work in this game, and how we can reuse a single room to create a variety of different room configuration styles for the map very efficiently, using a bit of logic that gets run on every time you enter a new room and reconfigures the room according to some variables that we can set on the map. We've created a player that we can move around with the left, right, up and down keys, make sure that it collides with everything correctly. We've created a means to detect when the player intersects a door, and some logic to react to that intersection and open the door if there is a door on that side, and to retain the state so that as you move from room to room on the map or location to location on the map, you return to the room and it's as it was before if you've already opened a door. So I think that's a good place to leave it for now. In part 2 we'll start to look at some keys, so that we can control which doors you can and cannot open based on which keys you've collected. We'll look at some screen facilities that allow you to display which keys you've collected and how you've collected them, and see if we can get it working so that we have a larger map area with some doors that you can use to get from room to room and find keys and unlock the rooms. So if you've enjoyed this so far and you're interested in keeping up, don't forget to like and subscribe. I hope to be able to release the second part of this in the next week or so, depending on how long it takes to put together. And if you've got any suggestions or thoughts on the game or on the way that I'm putting these tutorials together, just please do drop a comment down below, or even better, pop over to the Discord and we can have a chat. Thanks for joining me, and we'll see you next time.